So far in our examination of the titration curve, we have calculated the pH of a solution at the initial point when no base has been added. We have calculated the pH of a solution when some base has been added. We've also calculated the pH of a solution after equal number of moles of base has been added to the acid. In this video, we're going to now talk about the pH calculation of a solution after excess amount of base has been added and all of the acid has now been used up. The example that we will take a look at will be the addition of 120 milliliters of a 0.1 molar NaOH solution is added to 100.0 milliliters of a 0.1 molar HCl solution. At this point, we are going to complete our stoichiometric calculation. And again, we use our modified ice chart. And so from the calculation of the HCl, we have 0.0100 moles of HCl, 0.01200 moles of NaOH. We have no NaCl at this point in time and no water. But we don't worry about the water because our acid and base is in a water solvent. As we can see, the NaOH is no longer the limiting reagent. It is now the excess reagent, and our HCl is now our limiting reagent. And so when we take a look at the change, we see now that all of the HCl is now used up. And we again subtract the same number of moles from the NaOH. We now add the 0.0100 moles of NaCl, and we also add 0.0100 moles of water. In the end, we end up with 0 moles of HCl, 0.00200 moles of NaOH. We have 0.0100 moles of NaCl and 0.01000 moles of H2O. Again, when we take a look, we know that the water is not going to have any impact because we are in a solution where water is solvent. Also, when we examine the NaCl, we can see that Na comes from the NaOH, which is a strong base, so it will not further react with water. We see that the Cl comes from HCl, which is a strong acid, so again we know that the Cl here will no longer complete any further reactions. So that just leaves us with NaOH that is now going to impact the pH of the final solution. So now we go ahead and we are now taking a look at the concentration of the OH. Since NaOH is a strong base, we now know that it is going to completely dissociate, and so we are now going to get an equal number of moles of OH minus, and so the concentration is going to be 0.00200 moles of our NaOH divided by the total volume, which is 0.2200 liters. So when we divide this, we end up with 9.1 times 10 to the minus 3 molar. Since we have our OH concentration, we can calculate the POH, which is going to be negative log 9.1 times 10 to the power of minus 3, which yields 2.04. So now when we calculate the pH, we subtract 2.04 from 14, and we end up with 11.96 as our final pH. So one thing to note here is that after you reach equivalence point in a strong acid versus strong base titration, the final pH is controlled by the excess amount of OH that is present. And so in calculating the concentration of the OH, we are able to derive the POH value, and from there we are now able to calculate the pH value.